Okay, we're in section 12. It's the continuation of polynomial factoring. This is a section on special factoring, and certainly we'll go through this as a very short lecture. Basically, we're going to be verifying two things. We'll be verifying the difference of perfect cubes and the sum of perfect cubes. These are the two big ones that most students need to memorize for exams, all right? The other ones at the bottom of the page, again, I want to emphasize, you can certainly memorize things, but I do want to point out that these other forms, 1, 2, and 3, certainly can be done by trial and error. Now, someone's going to question, can you do these by trial and error, number 1 and number 2? Of course you can. All right, you can do that by trial and error. The problem for a lot of students, though, is the trial and error isn't productive. That's why we ask you to memorize these two. All right, let me go to whiteboard, and I got to do another share with you. It's going to be a short lecture. Then we'll get to examples. Whoops, not that. I'm sorry about that. Just give me a moment to warm my machine up. All right, so where are we? We're on the special factoring. And looking at that, my goal is to talk about two. All right, now there are more, but there are two that you need to know when you go into the problem set. All right, we'll do examples on these two. So don't think it's going to be just simply saying what these are. We will do examples on it. All right, now what two do they want you to know? All right, let's go over here. And I want to point this out. Whoops, let's shrink it down a little tiny bit. And I'm going to outline this for you. And this one over here, difference of perfect cubes, difference, perfect cubes. And they want you to know the sum of perfect cubes as well. So sum of perfect cubes, sum perfect cubes. And again, you should have an idea what perfect cubes are from just prior sections. So let me just summarize perfect cubes for you. They're going to be pretty simple. Let's just about the numerical ones. And numerical perfect cubes, let's see. Well, one's a perfect cube. That's certainly true. But one's a perfect everything. So let me write that down there. One's a perfect cube. What's next one going to be? 2 times 2 times 2, which is 8. What's next one going to be? 3 times 3 times 3, which is 27. And yet this list goes on forever. Next one will be 4 times 4 times 4, which is 64. These are perfect cubes. Let me write that down for you. So 1 cube, 2 cube, 3 cube, 4 cube, 5 cubed. Well, 5 cubed is going to be 5 times 5 times 5, which is 125. And I think you get the idea. This goes on for a very long time. All right, infinite. So what I'm going to claim over here is that you're going to have to memorize this. And when I say that, most students have to memorize this, that this thing over here, a cubed minus b cubed, can be factored into a product a minus b times a squared plus ab plus b squared. Now, someone's going to claim that if this is true, if we can do this over here and you got a quadratic, could you factor this quadratic? The answer is yes, we can factor this quadratic. Here's the deal, though. At math level, we do not factor this quadratic. You can try, but you're not going to get it. All right, you can try, but you're not going to get it. All right, let's do the other one. What's the other one going to be? Well, it's the sum of perfect cubes. And what's that going to be? A plus b, a squared minus ab plus b squared. So what I want to do is I just want to go to the side and verify this. All right, I want to verify that this is true. All right, so let me go to the side. And I'm going to verify this is true. Let's do one at a time. So I'm going to use uppercase letters. A cubed minus b cubed. We're claiming that this is a minus b times a squared plus ab plus b squared. Well, the truth is we can claim anything we like, but I want to see if it's true. So what do you mean, is it true? You gave it to me, it's got to be true. That's not necessarily true. Then you can write things down that are false. So you take this a and you can distribute across these three terms. I think it's a good idea to check. Well, what would you get there? You would get a cubed plus a squared b plus a b squared. Then what are you going to do? You're going to take this and distribute across these three terms here, one at a time. And what do you get there? Minus a squared b. Then what do you get? minus AB squared. And then what do you get? Minus B times B squared is going to be minus B cubed. If you were to combine like terms there, what would you get? A cubed minus B cubed. And why is that? These terms are disappearing. All right, so we get something pretty simple. Let's try the other one. Again, it's just a verification. They look similar. People do confuse these two. So let's write the next one down, which is A cubed plus B cubed. That's the sum of perfect cubes. And that's going to be A plus B, A squared minus AB plus B squared. All right, push that up. I'm going to verify it. How do you verify it? Distributive property. So this A is being distributed across these three terms. When I'm done with that, I would take this and distribute across these three terms. And what do you get? Let's take one at a time. And you're going to get A cubed minus A squared B plus AB squared. Then what do you get? You get plus A squared B minus AB squared plus B cubed. Combine like terms, and what do you get? A cubed plus B cubed. Now, why is that? These terms are disappearing. So we just want to show the factorization of a sum of perfect cubes. So let me go back to the notes, and I want to emphasize that these are the guys that you need to remember. All right, they're really important. You can remember these two when you get to the exam. That's going to be good. Now, when you're doing homework, you can have those written down in front of you. But again, when you get to the exam, I would say have those things memorized, right? Have them memorized. Now, I want to go the other ones for you. And this is where a lot of teachers said that these need to be memorized too. And I really don't think so. I'm going to claim over here, these are really kind of simple. And I'm going to say the difference of perfect squares, difference, perfect squares, A minus B times A plus B. Perfect squares type 1. All right, that's going to look like this over here. Perfect square type 2, it's going to look like this over here. These are perfect squares, by the way. They're binomial perfect squares. Now, again, if you multiply these things out, which I really want to do for you, and that's really me checking these things out, seeing if they're true. What would you get over here? Well, if I multiply this out, I get A squared plus AB minus AB plus B squared. What's nice about this? These disappear. Do you get what you expected to get, which is A squared plus, whoops, I made a mistake there. I just realized it. I'm sorry about that. Go backwards. That's minus B squared. I guess I was daydreaming, but it's good. It's good to go back and look at your work and know you're daydreaming. All right. Well, anyway, these cancel out. Then the big question is, do you get what you expect, which is the difference of perfect squares, A squared minus B squared? And you do. You get this right over here, A squared minus B squared. Let's go to the next one. My recommendation over here is to write it down, A minus B times A plus, I'm sorry, again, I'm misspeaking. What does this give me? I'll push it over a little bit. This gives me A squared minus AB plus B squared. Well, what would that give us? It certainly gives us A squared, right? It certainly gives us A squared. I see that. It certainly gives me plus B squared. And the two middle terms combined together is minus 2AB. That also works. Let's do the next one. And it's going to be A plus B. A plus B. What do you get there? A squared plus AB plus AB plus B squared. Are we getting what we expected to get? Well, we're getting the A squared. We're getting the B squared. The first and last term, pretty easy. We get the middle, which is 2AB. All right. Now, my claim over here is I really don't think you need to memorize these two over here. You can get these three here by trial and error. You can. Those three can get by trial and error. All right. The other ones, though, again, I really can't say it's enough times. You really want to make some attempt to memorize these by the time you get to the exam. When you're doing homework, though, you can have these things written down in front of you. The difference of perfect cubes and the sum of perfect cubes. Have them written down, all right? Now, again, can you get those by trial and error? Yes, but most students have a tough time with it. So we're saying try to have those things, but use them, make sure you understand how to use them, But when you get the exam, make sure you know those two formulas, the sum and the difference of perfect cubes. Of course, we're going to go through examples as well. Thank you.